Next, we have to see about the thread binary tree. In thread binary tree, a binary tree can be represented using array representation or linked list representation. When the binary tree is represented means by using linked list means the reference part of the node which does not have a child is filled with as null pointer. So in any binary tree linked list representation, there is a number of null pointer than actual pointer. Means if there are two n number of reference field, then n plus 1 number of reference field are filled with null. That is n plus 1 or null out of 2n. Okay. So this null pointer does not play any role except indicating there is a no link or no child. Okay. So we have to define the definition of threaded binary tree, which makes use of null pointer to improve its traversal process. In the threaded binary tree, the null pointers are replaced by reference of other node in the tree. These extra references are called thread. Okay. So we have to shortly define as threaded binary tree is also a binary tree in which all left child pointer that are null points it will be in order producer and all right child pointers are null, which can points to its in order successor. From this diagram, the binary tree, it is one of the example binary tree. It can convert into threaded binary tree. So first of all, we have to find the in-order traversal of that tree. Here, the in-order traversal means what? First, we have to visit which one? Anybody of you tell me? First, in-order traversal means first left child, then after root, then right child. Okay, left root, then right. So for that purpose, we have to find the in-order traversal of the above binary tree. So we can get as H D I, that is leftmost child of the root node. So we have to getting the node as right leftmost child. So H, D and I and B, E, then root is A, and we have to come under there is a no left child. So root, then right. Okay, F and J and C, J. Okay. So this is the in order binary tree traversal. when we represent using the linked list representation, the node as H, I, then E, then F, G, and J are the left child pointers or null. So this null is replaced by address of its in-order predecessor respectively. So I2D and E2B and F2A, then J2F, then G2C. This is a predecessor. Okay, but here the node H does not have any in-order predecessor. So it's point to the root node A. Okay, and node H, then I, E, J and G is a right child pointers or null. So these null pointers are replaced by address of its in-order successor respectively. So but here the node G does not have its in-order successor. So it points to the root node A. So how it will be possible here after converting the binary tree into threaded binary tree means it will be indicate with the dotted lines as a thread. So the H to D and I to B and E to B or E to A. Okay. So these are the threaded for a successor and a predecessor, which can be comes under the child pointers are null means if a null means the G to A, here it's null means A H to A. Okay. Then here F to A and E to A. If it is null pointer means directly threaded into A node, that is a root node. So this is a threaded binary tree. Before we have to conversion, first we have to find the in-order traversal, then after we have to indicate the dotted lines for the threaded. Okay, thank you. Then another thing in threaded binary tree, here we will see the threaded binary tree structure. There is a tree node, but may at most two children's. But if there are have any one children or no children means the link part in the linked list representation remains null. We already discussed. So the H node has a null pointer means it will be comes under the root node. Okay. So using the threaded binary tree representation, we have to reuse the empty link by making some threads. So if any nodes has some vacant in left or right child area, that will can be used as thread. There are the two types of threaded binary tree. One is single threaded binary tree or fully threaded binary tree. In a single threaded mode, there are another two variations, left threaded and right threaded. In a left threaded mode, if some nodes has no child, left child means, then the left pointer will be pointed into the in-order producer. Similarly, the right threaded mode, if some node has no right child means, that then the right pointer will be point to the in-order successor. So in both cases, if no successor or predecessor is present, then it will point to header node. So the H2 pointed to the A and I will be contained as the corresponding B and D. Okay. So then E has pointed to A and F has pointed to A. Here G has considered F and G, F and C, so it will be joined together with C and F. Here G is has a no more, so it will be considered to connect with root node. So for a fully binary tree, threaded binary tree, each node has 5 field. The 3 field like normal binary tree, another 2 field to store the Boolean values to denote the link of that side in actual link of thread. Okay. So how it will be possible means, the 3 field is left thread flag, left link, then data, right link, then right thread flag. This is a 5 field for denoting the fully threaded binary tree. Okay. Thank you, students. Then the next topic is threaded binary tree for inserting the element, okay, under the threaded binary tree. It is similar as a insertion in binary tree, but we have to adjust the thread after the insertion of the each element, okay. So now we have to see the how to insert the new new element into the node. So the insertion in empty tree means both left and right pointer of a temporary variable will set be as null and a new node becomes as a root node. So how it will be possible means we have to assign the root node equal to temp, and temp tends to left equal to null and right equal to null. Okay, so in under the case 2, when the new node inserted as a left child, after inserting the proper place, we have to make in left child node, and right child points to the in order producer and successor. So the node which has to be in order successor, so the left and right child of the new node will be considered as temp tends to left equal to the point tends to left, and the temp tends to right equal to the pointer. Okay, so the before insertion the left pointer of the parent, that is the parent tends to left. Okay, so the parent was a thread, but after insertion it will be link point to the new node. So the parent of the link thread equal to false, the parent of the link tends to left equal to temporary. Okay, so here it is one of the following diagram for inserting the new node as a left child of its parent. So 20, then the left of the root node as 10 and 30, then 5 and 15. Okay, so how it will be possible for inserting the left child of 14? We have to insert as a 13. Okay, how it will be possible means the producer of 14 becomes the producer of 13. So the left thread of 13 point to 10. So the successor of 13 is 14. So the thread 13 points to the left child, which is 13. Then left pointer of 14 is not thread now. So it points to the left child, which is 13. In case 3, when new node is inserted as a right node, that is a right child, the parent of temp is it in order producer means the node which was in order successor of the parent is now the in order successor of this node temp. So the left and right thread of the new node will be considered as temp tends to left as a parent and temp tends to right as a parent of the right. So before insertion means the right pointer of the parent was third thread, but after insertion the link point to the new node. So further we have to consider the parent tends to the or thread equal to false and parent tends to right equal to temp. So by this example, we have to insert the right child of the parent, that is after we have to inserted the 15, we have to change the sum of the things, that is the leftmost of the 14, there is a successor of 15, then the successor of 15 can be pointed to the right of the 16th node. Okay, so by the implementation, we have to, using the thread binary search tree, we have to searching the element of the tree. If the key is already present, then we have to return the new key is inserted at the point where it searches terminates. So we have to find the key, or when we have to reach the null left or right pointer. Here, all left and right null pointers are replaced by thread, except the left pointer of the first node and the right pointer of the last node. So, here we have to search will be the unsuccessful when reach of null pointer of the thread. So this is by using the C++, we have to implement the insertion in binary tree traversal. So by using the struct node, we have to using the linked list parameter. So we have to declare left and right and inserting the data element for and also we have to declare the data as boolean. Okay, so L thread left thread and boolean for right thread. So this is the declaration part of the corresponding program. Then after using that insert function using struct node, we have to, the root has been pointed, then if not pointed means the key pointer can be already exist or not. We have to check, and if it is check means it is a represent as a duplicate key, otherwise and return root. Okay, then we have to update the parent pointer. Under the parent pointer we have to move the node into left subtree. Okay, so if we taking the condition, checking the condition, if the pointer tends to thread, that is a L thread, left thread equal to false means the pointer equal to pointer tends to left. Otherwise, the pointer tends to right. The create a new node means the node, the temporary by using the temporary variable, by using temporary variable, we have to get the new node. Okay. Then after we have to assign temp of the information. Temp tends to information equal to key, and temp tends to L thread equal to true and right thread equal to true. If the parent equal to null means the root equal to temp, and the temp tends to left equal to null and right equal to null. Otherwise, the key will be performed. Okay. So the parameter tends to left means it tends to temporary left. The parent means it tends to temperature right. Then L thread, there is a no thing, so it will be considered as false. And the temp has been considered as a parent turns to left. Okay, so if it is true means the three conditions will be satisfied, otherwise the else part could be displayed based on the same thing. Here it is a left child, here it is a right child. Okay, so then after we have to return the in order successor during or thread. If the pointer, we have to check the pointer tends to or thread equal to true. If it is true means the pointer of the data can be move to the right node. Otherwise, it can be moved to the left node. In order traversal means what? In order traversal means what? Left root right. Okay, so visit the node as left root 9 right. So the left thread of that pointer can be checked whether it is it true or false. If it is false means the pointer can be tends to left. Otherwise it can tends to right. Okay, so then after we have to check while condition pointer not equal to null. So we have to print the in-order successor of the pointer. So under the main function, we have to insert the each root node as here. Then we have to call the in-order root function. So how it will be displayed the output means then how it will be outcome means here 5, 10, 13, 14, 16, 17, 20, and 30. You know, by using that threaded, we have to get the corresponding result of the insertion of threaded binary tree. Thank you.